So today we're going to talk about chemical equations. This is mainly for those of you who are not going to be here. We're starting a new unit this week. This unit is talking about chemical equations. So this is part one of our notes. Now, chemical equations are defined as a condensed statement about what is the chemical reaction is going to be. So we've talked about how we've done all the different chemical equations, how they represent changes in the bonding energy as it takes place, what happens when we put them all together. We've done a few of these over the past, but we haven't really done any balancing equations or anything along those lines yet. But we do know the difference between reactants and products. Reactants are going to be on the left side of our arrow, and products are on the right. So basically the arrow shows us what's happening in the reaction. The reactants are the substances that exist prior to the reaction. The arrow is the reaction itself, and the products are what exist after the reaction. So whatever a final result is. So when we did our experiment using different ionic compounds and we created nice pretty colors, those are when we're talking about creating our products by combining them together. The change in color shows us the reaction. Now, arrow, these stands for yields or produces. So basically what is happening during the reaction is all in here. Now there can be symbols above it. So it can be an element symbol. This means that there is a catalyst. A catalyst is a particular substance that will increase the rate of reaction. So in other words, either create more product or make the product appear faster. A squiggle means that there is electricity, so that means some sort of current was used to create this reaction. And then the delta symbol or the delta H symbol is with heat. And then of course the double arrow means that it can go back and forth. A lot of gases use when they combine inside of a container, they can go back and forth with the double arrow. Now, verticals on the signs means that a substance leaves the reaction as a gas. So an up arrow means that, and a down arrow means that a solid is formed with a precipitate. So we talked about, we saw that in our lab with the ionic compounds as well, that there was some sort of precipitate that existed. So if you were writing down that particular equation, you would put a precipitate cells at the bottom of the reaction of the solution. And an arrow means that a gas leaves it. So that means that there must be, if you were doing the present composition of a reaction and something was different from the products and the reactants, you would assume something left as a gas, because the law of conservation of mass means that we can't change. So if we showing the phase of the states of matter, so G means gas, L means liquid, and it is L because we do it in lowercase. AQ means dissolved in water or a solution, and then S is a solid. So if you see, basically this means aqueous. So you have sodium as a solid. Hydrochloric acid right here is an aqueous, or the solution dissolved in water. Sodium chloride is also turns into this, and hydrogen turns into gas as it leaves the reaction. So that's what this means. That's what all of these nice little things mean in there. Now, coefficients. This is how we balance our reaction. Coefficients are numbers written in front of formulas. They indicate the ratio of each compound in the equation. So we have to balance on both sides of the arrow. So the number of atoms of each element on the reactant side have to equal the number of atoms on the product side. So that's where we get our coefficients from. So for instance, if we go back and we look at our first reaction that we have here, we have 2H, O2, H2, H2O. So H and H's balance, but our O's do not. So that means we have to double this side, but now we've doubled our H's, so now our H's must double again. That's how the balancing on both sides of the equation with coefficients works. So make sure that the ratio is equal, make sure both the numbers are the same on each side, make sure that we are good to go. Now, we have different types of reactions. we have endothermic, in which the energy is on the reactant side and it feels cold to the touch, so it sucks in the energy from the reaction. So this is like when water turns back into hydrogen gas and oxygen gas. It takes in energy. You put your energy on that side, or you put in your number for, so for instance, calories or kilocalories are an example of energy. Exothermic, this is an energy on the product side. It feels hot, so it comes out. You'll feel heat to the touch as you have a reaction. A lot of times a gas will be released with this because of how we understand energy to work. So if you see smoke coming off of something, it's more than likely that it is some sort of exothermic reaction. So energy on the product side. So you'll see that energy symbol on the product side. So this will be your quick into the notes equations. In class, we'll probably do it together, but make sure that you are answering each question. So which equation is exothermic out of 1 and 2, or A and B? How many carbon atoms are there in this particular product? How many nitrogen atoms are in this particular thing? So remember, when we do the multiplication, you have to multiply everything inside of the parentheses first, and then you multiply the whole thing by our coefficient, or the number in front. Name the compound that precipitates in the following reaction. So, got to know your arrows. That is all for today. Make sure that you are participating in this, and have a nice day.